From this lesson, we're going to start converting JavaScript files into TypeScript files. And after we are done with that, we're going to integrate TypeScript in Vue components. So let's start with the first JavaScript file, activities.js. First of all, let's change extension of this file on TS. We're also going to use strict mode of TypeScript in order for TypeScript to be as strict as possible when notifying us about possible errors. So let's open up configuration file tsconfig.json, and to enable strict mode, let's add property strict with the value true, like so. And if we'll go back to activities.ts, right away we can see several places that are highlighted. Those are the places where TypeScript couldn't automatically determine the type. So now we're gonna fix all of those issues one by one. Let's go from the top. And the first variable we're going to type is this activities reactive variable. This variable is supposed to store array of activities objects. Let's open up our application and see what shape each activity object has. As we can see, activity object consists of three properties: ID, name, and seconds to complete. And in order to describe an object of such shape, we're going to use an interface. So let's declare a new interface in here with the name activity and describe the shape of activity object. As we have just seen, this object should have three properties: ID, name, and seconds to complete. And now let's specify type for each of these properties. So property ID should be string, property name will be string as well, and property seconds to complete will contain numeric value. Therefore, it will have a number type. And if we'll take a look at activities reactive array, we can see that TypeScript has determined the type automatically, but this is not the correct type. So we're going to explicitly specify the type that this variable should have, and we can do so by using generic type argument when calling function ref, like so. And this way we're telling TypeScript that activities variable should store array of activity objects. Let's move on and switch over to direct activities computed property. As we can see, TypeScript was able to automatically determine the correct type for this computed property, and the type was determined based on the return value of the closure that we have passed to computed function. But what if we'll make mistake and accidentally return wrong type from this closure? This way, direct activities computed property will get wrong type. So I prefer to explicitly type this property by using generic type annotation, like this. And after this, if we're going to return wrong type from this closure, TypeScript will notify us right away. Let's also explicitly annotate return value of the closure that we pass to filter method. So this closure should return value of the boolean type. And just to make our intention explicit in here, we're going to manually compare seconds to complete to 0, instead of letting JavaScript convert type for us. And now TypeScript is happy, we are returning boolean value in here. Let's move on. The next computed property is activity select options. Let's take a look at our application and see where this property is used. And it's used on timeline items page in order for render this select list of activities. And if we'll inspect this component in Vue DevTools, we will see that every object from activity select options array should have two properties, value and label. Therefore, we have to make sure that generate activity select options function returns proper value. As we can see, it returns array of objects with two properties, value and label. So let's go up and declare a new interface to describe this data type. We'll call this interface activity select option. So it will have two properties, value and a label, and both of these properties will be string. So now we can use this newly declared type to use as type annotation for activity select options computed property like this. And this way TypeScript knows a lot more about type of this property. So let's keep going. Next up is function initialize activities. It takes one parameter, which is some kind of a state. We don't know yet what this state is, since it is declared in a different JavaScript module. For now, let's use type annotation any, which is basically going to disable type checks. It's actually not recommended to use any type annotation, but we are only doing this temporarily since we are converting every JavaScript module in isolation. Later we're gonna get back to this place and update this type annotation with proper type. And also I prefer to explicitly assign type annotations for return values of functions, because if, for example, we're going to make a mistake and return wrong data type, TypeScript is not going to tell us that we have returned wrong data type. So let's use explicit type annotations for return values. And since this function is not supposed to return anything, for such cases we're using type called void. So let's get back the previous code and move on to the next function. So for this function we're gonna use type annotation activity for the first parameter. This is that type that we have declared earlier in this lesson. And this function also does not return anything, so I'm going to use void data type as a return value in here. Next up is update activity function. The first parameter will be of type activity. And as for the second parameter, we're temporarily going to use any type. And in the future lessons, we're gonna come back to this place. This function returns activity object, so let's explicitly state it and use activity type. The next function is delete activity. As the first parameter, it also accepts activity object, and as a return value, we use void, since it does not return anything. For the next function, the first parameter will be an activity object. We are just destructuring this object and extracting only one property, but we still can use type annotation activity. And the second parameter should be a number. And as we usually do, let's specify explicit type annotation for the return value. This function is supposed to return numeric value. Next one is calculate completion percentage. As the first parameter, we're passing number, total tracked seconds, and as the return value, this function also returns number. Moving on to total activity seconds to complete computed property. For this property, TypeScript was able to automatically determine the correct type, but we are still going to explicitly annotate the return value of the closure that we pass to method map right here, because if we're gonna make a mistake and return wrong value by accident, TypeScript is not going to tell us about it unless we use type annotation for return value. And as for the closure of the reduce method, as we can see, TypeScript was able to properly infer types for these both parameters, total and seconds. And finally, there is one more function in this file, which is generate activity select options. So the first parameter should be an array of activities. Let's use a proper type annotation. And as for the return value, this function is supposed to return array of other objects, specifically activity select option objects. So once again, if we're going to return a wrong value from this closure, we are not gonna get any error. But if we're going to use explicit type annotation for return value, we're gonna see an error. So let's keep this type annotation right here. And in addition to that, if we'll try to use unknown property, we're gonna see that it does not accept this property because earlier declared interface called activity select option does not contain that property. So let's get rid of that extra property, apply formatting to this file, and finish this lesson. The link to the source code of this project will be in the video description.